live in 5, 4. Welcome back, everybody, to our discussion on segment routing. And I would like to thank our member of the audience today who helped me out here with my config. There was a command that I was missing on iOS XR in order to turn the process on. Okay, again, we're not getting into the nitty-gritty details of segment routing. We will come back and talk more later about what do these configs actually mean. Okay, the whole goal, though, is that we need to separate from the router's point of view what labels are being used for LDP, what labels are being used for segment routing. Okay, segment routing calls this the global block. Now, the final verification of this either way, though, is show MPLS forwarding table. From the forwarding table, the important point here is that I now have a label that is bound to the exit loopback of the PE. Okay, it's still the same number we were using before, 24004. The exit number is now different. This is based on some sort of segment routing value. And you can see inside of the database, we also have these segment routing adjacencies. We have these segment routing prefixes. We don't really need to go into the details again, other than to say, what did segment routing accomplish for us but to create a transport label? Okay, so if we jump back now to our final verification is end-to-end transport on the customer segment. Specifically in this case, this was pinging between router 6 and router 7. Okay, so we can tell that data plane is working. Okay, so everything is fine from the customer's point of view. We now do a trace route, and let's see what the result of this is. Okay, previously the trace route output showed us that we were forwarding with 2 labels over the MPLS core. Top label being the transport label, telling us what is the exit PE out of the network, and then the bottom label, the VPN label, talking about our final destination. So from router 6, we now do a trace route to 7777. The source is 6666. We're going over the MPLS network. We're using a new transport label, 205103. This is now the number that it was being generated by segment routing. However, if we were to look at this from a data plane point of view, and again, how can we see the data plane, Brian? We can do a capture inside of our virtual topology. So in Viral, we're going to go to the simulation. We're going to go under interfaces. We're going to go to XR1 and capture on gig 0. So to the unmanaged switch, we create a traffic capture. Okay, leave the default options, create. We go back to the customer, we trace, we ping, we do whatever data plane operation that we're doing. And now we want to look at the result of this. Okay, result of this under traffic capture, okay, is XR1. Download the config, or not the config, download the PCAP, the packet capture. Okay, this open in my other window. Get this correctly. Okay, so here is the PCAP for XR1. Okay, so now let's search for UDP. Okay, UDP because we were doing trace routes. Cisco trace route is Linux trace route, Unix trace route, which means it's UDP echoes out and is trying to solicit ICMP port unreachable and ICMP time to live exceeded as it comes inbound. So UDP out, ICMP error messages back in. Okay, we should see the ICMP, or excuse me, the UDP message coming in. It is UDP inside of IP, inside of Ethernet, inside of layer 1. Okay, but then we encapsulate it. Okay, originally it was IP in Ethernet. Now it becomes what? IP in MPLS in Ethernet. 2 labels, 24010 at the bottom. From XR1's point of view, we would see this being generated by BGP in the control plane. If we show BGP, VPN v4 unicast, we have the destination. Okay, where is this packet going? This packet is going to 7777. We look at the destination, which is in what route distinguisher? It's route distinguisher 11, 11, 11, 11, colon 2. Prefix is 7777/32. From BGP, we are learning we should use label number 24010 when I am signaling the exit PE on the other side in the data plane about where does this packet need to go. because there is a potential case where we land on the final PE. PE looks at the destination 7777, and hey, maybe this overlaps between multiple customer routing tables. That's why the VPN label is needed. Not that it can't do the lookup itself, it's possible that it might not even know what table to do the lookup in. Maybe both customers have overlapping address space. That's ultimately what the VPN label is trying to signal. Now, from our point of view, though, the VPN label did not change. If you go back to our previous captures a couple hours ago, we were already using 24010. So really what changed here, Bri, is 205103. If we look at the show MPLS forwarding table, it says a packet comes in and you're trying to reach what tunnel destination? You're really trying to reach 13131313 because this is what our BGP next hop is. So in other words, what changed about the services? Layer 2 VPN, Layer 3 VPN? Nothing is the answer. I did not need to update the config of any of the VRFs, any of the route distinguishers, any of the BGP config. The only thing I changed here was IGP. I'm running a flat IGP everywhere, which in this case is ISIS. If we look at the show run router ISIS, okay, we turn segment routing on. Okay, someone set this number here. I'm not 100% sure if that is required. Okay, we saw before though it wasn't working. So whatever has changed here, it is now working. If we show run segment routing, okay, someone had set the global block. Okay, someone, I mean literally someone. One of you guys did. I said log in, help me troubleshoot. You logged in, set these numbers, now it's working. But the key is, if you read the spec, the default global block should be the default global block anyways. You shouldn't have to set it. That's just some issue with the syntax that they didn't deal with yet. But what's more important about this, what we care about, is did the binding actually occur? So we need to look at the CEF table. Tell me from the CEF table, what does it look like inside of VRF Brian? You're trying to reach 7777/32. What are you really doing? You need to impose two labels, Brian. You're going to put 205103 on the top of the stack, 24010 on the bottom. You then do your next hop lookup to whoever your layer 2 forwarder is, which in this case would be the MAC address associated with this particular next hop, and then we forward the packet out the interface. So ultimately what changed is LDP no longer exists. If we now look at the show MPLS LDP neighbors, I'm no longer running LDP. What am I running? I'm running segment routing. If we now show ISIS database detail, hopefully this shows me what I was originally looking for, which is what are the segments? Okay, now I don't believe that this is actually even supported in terms of the verification, so I don't know where in the database we would find this, but somewhere essentially what this is an extension in what we call the type length values or the TLVs of the ISIS database. If you were running segment routing for OSPF, that would be encoded in your opaque LSAs. Opaque LSAs being the extensibility for OSPF. So let's go ahead and take this back full circle. What is segment routing, Brian? Segment routing is a way to simplify your MPLS core. Simplifies your MPLS core because you're reducing the control plane protocols. You technically do not need label distribution protocol anymore because now this functionality has been ported into IS to IS, intermediate system to intermediate system routing, or OSPF version 2, not OSPF version 3. We'll talk later about segment routing v6, SRv6, which is highly integrated from a marketing point of view, what we would consider 5G now in terms of wireless. But ultimately, segment routing is going to be a big deal going forward. Okay, when I talk later about, hey, Brian, we don't even need MPLS anymore, I can encapsulate you directly in v6. That's going to be amazing. We'll have one unified data plane that technically would be able to support everything. Okay, and as someone said here, Mr. J, thank you, Mr. J, is still logged in. I really appreciate that. Is show ISIS database verbose. Okay, that's what I was looking for. It says here we have segment routing enabled. What is your segment routing global block base number for the range? 19500. I start here, I count up by 65535. That's the label numbers that I'm going to use. So we don't really care about these details, right? We just want to know, is it on? So we ran some commands, turned it on. Okay, of course, we need to figure out what are those commands. You want to implement it, but you're not really implementing this today in production, not by looking at the documentation and then just pasting commands in, right? You're doing some sort of proof of concept. This is our proof of concept. So now I'm going to save this config, post it for you guys, and then later what you'll be able to do is load this topology up. You see router 6 is forwarding to router 7 using iOS XR VBoxes as the data plane for the MPLS network, in which case they are also running segment routing. So thank you everyone for attending today's INE's Ask the Expert. We actually solved our problem for today, which I'm very, very happy about. So thank you guys for joining me today, Sunday, March 24th, 2019. And of course, this video will be added to our streaming library later. Check streaming.ine.com. But for now, I will be rendering these to YouTube for short term. So in a couple hours, these videos will be posted. Questions that you guys have, please feel to type those into the Q&A box. Email me, bmcgann@ine.com. Please, any suggestions that you have for further sessions. The whole idea about this is that I need to cover all content. I don't care what order I do it in. I'll do it in whatever order you want. So let me know what your questions are. I'll format the class in that format and deliver it. Somebody said to me today, hey Brian, how does segment routing work? Look what happened. We now know, at least on a very basic basis, right? What is segment routing? What does it do? Next time you need to give some sort of talk to your customer, maybe some sort of sales meeting, you can bring this up. Hey, have you guys heard of segment routing? Segment routing is going to replace LDP. Segment routing is going to allow us to do IPv6 any-to-any natively on the internet down the road. We will be able to do Ethernet over IPv6, Ethernet over IPv6, Fabric down the road eventually with segment routing. What? Maybe. Check in 5 years. We'll see if that one actually comes true. So thank you everybody for attending today. Keep an eye on my Twitter @BrianMcGann, and I hope to see you back later this week for additional sessions of INE's Ask the Expert.